In this video, we're going to learn how to graph logarithmic functions. So before we start sketching, I want to show you a brief intro to where this graph is really coming from. So if you were to recall exponential functions, so we say if you have f of x is equal to a to the power x, and assume that a is greater than 1. So then we know the graph of this function looks something like this. And it goes through this point 0, 1, which is the y-intercept. So this is the graph of a to the power x. Now, if we were to graph the inverse function for this given function, we would have to reflect the given graph about the line y equals x. So let's suppose this is the line y equals x. So if you reflect a to the x about this line, you will obtain this given graph. And this graph is what we call the logarithm base a of x. That is the inverse function of the exponential. And this point that it passes through is now 1, 0, because that's the reciprocal of 0, 1. And because the exponential had a horizontal asymptote, now the logarithm has a vertical asymptote at x equals 0. And then you can also talk about the domain and range. So the important part about logarithm function is that you must know what is the vertical asymptote, and you must also know its domain and range. And it's good to label some points on the graph too, but more importantly, you must know these 3 details as you talk about any logarithmic functions. So having that knowledge, now let's start graphing some logarithmic functions. So let's start off with this one. So our first example would be, let's graph the function f of x, which is equal to negative log base 2 of x. So it doesn't really matter what the base is, the shape will still be the same because we're assuming the base is positive and greater than 1. So we're going to use transformation of functions to come up with the graph. So first thing you want to do is identify its vertical asymptote. So the way you would do it is take what's inside the logarithm. In this case, it's x. So you set x is equal to 0. So that will be a vertical asymptote. And then from the sketch, we'll figure out the domain and range. So let's go ahead and graph. So we're going to start off with the basic shape. So logarithm of any base greater than 1 will have this shape. So we can call this log base 2 of x. And then the negative in front of the logarithm, it means that we're going to reflect the function about the x-axis. So our graph is going to be reflected, so it would look something like this. So you would have this graph as the reflection about the x-axis. So this is the graph negative log base 2 of x. And as you can see, the asymptote didn't move from the original graph, so you can use a dotted line to indicate that x equals 0. And from here, we can write down the domain of f. So we know the domain is 0 to infinity. We can also talk about the range of f. That's going to be all real numbers. And we have a vertical asymptote, which we solved at the beginning of this problem, which happens to be x equals 0. All right, so, and then you can also label this point, that's 1, 0. Now let's go ahead and do another example. Let's again use transformation of functions to graph, say f of x is equal to log base 3 of negative x. Okay, so first thing you want to do is again find the asymptote. So we have a vertical asymptote. So you take what inside the logarithm, set it equal to 0. So we have negative x is equal to 0, which simply means x is equal to 0. So that's our vertical asymptote. And then from the sketch, we'll figure out the domain and range. So let's go ahead and sketch this function using transformations. So here we have log base 3. So again, it's still the same shape as the basic shape. This would be the graph for log base 3 of x. Now that in negative inside the parentheses, this represents a reflection about the y-axis. So we're going to take the original graph and reflect about the y-axis. So our graph would now be, so if I take one point that's on the graph, let's say negative 1, so it's going to reflect, it becomes negative 1, and then just maintain the same shape, but facing the other direction. So it will look something, so let's do it again. It looks something like this. So that will be the graph of log base 3 of negative x. And now we can write down the domain, range, and asymptote. So we have the domain, which is negative infinity up to the asymptote, which is 0, open. Range is again all real numbers, so negative infinity to infinity. And we have the vertical asymptote, x equals 0. All right, so I hope this makes sense. Let's continue and do a couple more examples. So let's go ahead and sketch this one. Say we want to graph y equals, let's add more transformations to it. So let's do log base 3 of x plus 5 minus 2. So we want to graph this. So again, first thing you want to do is identify your vertical asymptote, which simply by taking what's inside the logarithm, setting it equal to 0. So in this case, we're going to take x plus 5, set it equal to 0, and you solve for x, so you get x is equal to negative 5. So that's your vertical asymptote. And then from the graph, we'll figure out the domain of f. Well, in this case, I wrote y, so I wouldn't put f. Let's just say domain. And then we'll figure out the range. Okay, so let's go ahead and start from our basic graph. So we have log base 3 of x. So here is log base 3 of x. Now let's identify these transformations. So if you recall from previous info, we know that this is a shift left or right, so it's x plus 5. So we're actually going to go left 5 units. And then the minus 2, this is a vertical shift up or down, so we're going to go down because of the negative 2 units. Okay, so let's do that. So let's go left 5 units. So we take the point 1, 0, which is on the graph, and go left 5 units. So 0, 1, 2, 3, 4. So that's 5 units. So this point is sitting at this 4, 0. Now, as we also have to label the vertical asymptote, which we solved for it, which is x equals negative 5. So let's suppose this is negative 5. So let's label that using dotted line. So that's our vertical asymptote, x equals negative 5. And we know the graph passes through negative 4, 0. So something like this. So this is the graph of log base 3 of x plus 5. And now from here, we're going to go down 2 units. So that will be the final sketch. So let's do that in pink. So let's go down 2 units, 1, 2. So the point negative 4, 0 is now moved to negative 4, negative 2. And then we just make the same sketch. So I'm going to do my best to sketch this. It'll look something like that. So it looks something like this. So I didn't really make it, label it very appropriately, but hopefully you got the idea. Let's label this point -4, -2. There is an x-intercept and there is a y-intercept. So you can go ahead and find them by setting opposite components equal to 0. But pretty much that's the graph of y equals log base 3 of x plus 5 minus 2. So that would be your final sketch. Now from the sketch, let's figure out what is the domain. So the domain of this function, so we're looking at the pink, it's going to start from its asymptote, which is -5, and then go to infinity. The range is all real numbers, so that would be -infinity to infinity. And we have the asymptote, which we solved algebraically. Okay, so let's do one more example. So let's try this one. Let's try to graph the function, say g of x, which is equal to negative log base 6 of x minus 3. So let's go ahead and do the same thing. So we're going to find the vertical asymptote first, and then we'll apply transformations. So the vertical asymptote, we take what's inside the logarithm, x minus 3, set it equal to 0. So we have x equals 3 as the vertical asymptote. And then we'll figure out the domain and range of g from our sketch. Now, let's also identify what are the transformations. So the negative in front of the logarithm, this represents a reflection about the x-axis. And then this -3 with the input variable, it represents a left or right. So this is a -3, so this is going right 3 units. Okay, so now we're going to sketch this function. So here's our xy plane. Logarithm base 6, okay. We still have the same shape, something like this. And let's label that point 1. So this is log base 6 of x. And then we reflected about the x-axis. So our graph would now look something like this. So that's the reflection about the x-axis. So let's call this negative log base 6 of x. And then we're going to go right 3 units. So I'll move the point 103 units to the right. So let's do that. So we have, so let's do, let me just extend the x-axis a little bit more. So let's move 3 units to the right. So we have 1, 2, 3. So the point 1, 0 is now at 4, 0. And we also want to label our asymptote, the vertical asymptote, which we solve it to be x equals 3. Or you can think of when you move x equals 0, 3 units to the right, it's going to now end up at x equals 3. So there are 2 ways you could always find the vertical asymptote. Okay, and now we make the same shape, and that'll be our final sketch. So let's do that in different color. So here's our final sketch. So we have something like that. So that will be our sketch for g, which is negative log base 6 of x minus 3. So that will be the sketch. And now from here we can identify the domain. So the domain will start from the asymptote and go to infinity, and range is all real numbers. So let's write down domain and range. So the domain is 3 to infinity, and range is all real numbers. All right, so I hope this idea makes sense.